at the expected value of Sick Kids Lotto, which is popular lotto in Toronto, and they send you a bunch of information in the mail. So we took that information. We're going to calculate what the expected value is. Okay, so first of all, there are a ton of prizes, and we went ahead and we listed all the amounts that you could win. Okay, and we even calculated what the minor draw was, and these little 44,425 chances at an average of $75 a prize, which is important. So we discovered that the exact amount of tickets that are being printed is 122,839. So we're talking about expected value. Expected value, the probabilities must add up to 1. Okay, so you can think of it like the sum of all the probabilities is really the winning tickets in this lottery. So winning, and I guess maybe green would be for winning, like money, okay, plus the losing tickets. So we'll say L tickets. ETS. Now, both of these are going to be over the total amount of tickets that are sold, and that number happens to be 122,839. So 122,839. And I'm going to talk about this concept very quickly so that we can kind of go on. Whenever you're adding fractions that have common denominators, we can just write everything over the one denominator, right? So really now it's going to be the probabilities are your winning tickets. So we'll just say W plus L, so winning tickets plus losing tickets over 122,839, and that will equal 1 because you only get winners or losers. Those are the only two options in these. Okay, so we know losing tickets, the expected outcome, so the dollar value of a losing ticket is $0, right? You didn't win anything. Where on our other hand here, winning tickets is very, very diverse, okay? So we're going to have to break up all of our winning tickets. We calculated that there are 50,310 winning tickets, and they are all very, very much split up. So we're going to make each of these their own little amount, okay? So you have a 1 in whatever chance, okay? So whatever we calculate from here, and this is where we multiply the expected outcome, that's what the X value is, times the probability of that outcome happening. So the sum of the value of the prize times the probability of the prize is equal to, well, we know, and I'll put the number times the amount, so the amounts we'll put in a different color, and the number of tickets we'll put in black, okay? So there's a 1 chance at $10,000, okay? So one guy gets a chance. Oh, did we change the color? I didn't change the color here. I wanted winning to be green and losing to be brown. Okay, times $10,000, right? So there's one of the expected probability. And we'll put everything over this number in the very, very end. So that's the very first opportunity, okay? The next opportunity, okay, and this one is one that's split. You have 1 chance at 60,000 and then 24 chances at 1,000. So we're going to write that as 2 separate ones. We have, again, one of those tickets will give us, we say 60,000? I think so. One ticket gives us $60,000. And the other gives you 24 shots at $1,000. Okay, and this is pretty much the process of building all the expected values. The probability of the event happening times the amount you would get for that. So we'll just kind of go through this. Then you get a 1 chance at 25,000. Okay, so let's take a look at that. You get another 1 chance at 25,000. And really, we could just write this at 25 because we know 1 times these numbers. It's going to be that. We're just going to continue it on to the next line, and then we'll start to calculate them. Another option. Here, 5,850 prizes. One of them is at 50,000. The other 5,849 are at 100. So very, very different. So we'll do our 1 at 50. So we get 1 at 50,000 bucks. And the other 5,849, I'll double check that, are at $100. So significantly less in terms, and a lot more prizes at that point. Yep, great. You have a 1 grand prize at $1 million. Okay, so that's our grand prize in this lotto. So 1 shot at $1 million. So we're just kind of listing all of the things here. Oops. We get a shot at 55, a shot at 20, 2 shots at 5,000. Actually, there's 3 shots at 5,000. So I'm going to pair those all together, okay? So 55 at 20, 3 shots at 5,000. So 1 shot at 55. So many winning differences. 1 shot at 20, we said. Say plus 1 shot. I know I do 2 pluses there, but 1 shot at 20. 3 shots at 5,000. There were 3 different prizes, all worth 5,000, so we just clumped them all together. The probabilities are all the same technically. And then we get a shot at 4,000 and a shot at 1,000. Shot at 4. Holy smokes, there are a lot. So I'm going to get you to help me start calculating this. 1 shot at 1,000. And then finally, we'll do it on the next line here, the very last one. You get 44,425 shots at $75. Okay, 44,000. I already forgot the number. 425 shots at $75. Okay, and then there's actually one other one, and I'm going to write it in, but it won't really do anything. Then you get, because remember talking about how many losing tickets there were? There's 72,529. You get 72,000. Oh, 529? Oh, yeah. You're so good. 529, thank you. Shots at 0. Now, you can write that in for expected value, right? But what is 0 times this amount? 0, and anytime we add 0, it doesn't do anything. So this kind of cancels itself out. But these are all of the total possibilities, and they're all above this, okay? So we're going to add them all up and then write out whatever that is above this idea here. Okay? So we're going to have to add them together here. And I'll try to do some adding while I put them together. But we get 10,000 plus 60,000, that's 70, plus another 24,000. What do we got there? That's 70, 94,000. So 94,000. I'm going to keep track as I go. Plus a 25,000 to 50, so that's 75,000. Plus another 75,000. Plus, oh, this value here is going to be 0, 0. $584,900. Plus another million. 55 shots at 55? That's not true. This one must have been the number 1. 55 plus 20 plus 15, so that's 35. 60, 90, so another 90,000. It does. And then another 5,000, so add 5,000 more. And then finally, this one I need you to calculate here. What is 44,425 times 75? 24,000. I can try to join you along. 44,425 times $75. Yeah, it looks like it. 3,331,000. Okay, let's write it down. So it's 331,875. Wow, that's a lot. 875. So again, I'm still just compiling everything. It's all technically over that 122 total number of tickets. 839. Okay. So let's add them all together here. Are you going through that at the moment?
Yeah.
Great. So we'll let you kind of go through it. Significant amount. It's got to be like 5 million. And in fact, I think we know what it is because they told us what it was going to be. What's that total amount there? I think it's going to be 5 million-ish.
Oh, it keeps giving me an error.
Lost it? Okay, give me a second. We looked it up and we added it together, and this is the number we got. But we remembered looking on the Sick Kid Lotto, and they said this was the prize value. So we've probably made some error somewhere, but the point of this is to find the expected value. Okay, so we'll use what they say it was and what we calculated it to be. we found out we expected the prizes to be worth $5,179,875, and that's what we got when we added these together. I probably made an error somewhere. They said that the total prize amount was $5,221,477. We divide by the number of tickets sold, and you'll notice that the outcome is very, very similar, whether it was our calculation or theirs. We expect to get $42.16, and they said that you should actually get $42.43, so about 30 odd cents or 20 something cents more. But here's the thing: a Sid Kids Lotto ticket is $100. Okay. Now there are a couple ones where you can get like 2 for $150, and they make some deals, but you don't really ever know what it is they're going to sell all the tickets for. So there's one rate. Let's say they sold all of those tickets for $100. Okay, that's 122,839 tickets for $100. There's the other option, and I think it says it in here. You can get 20 tickets for $100. No, sorry, $900. $900 for 20 tickets. So we'll find out what that ticket unit rate is. And that's probably the lowest one. So we're going to calculate two different ones just because we want to get an idea here. So 9 divided by 20. $45 is our one amount, 100 is the other. So let's take the highest expected value, okay? This is what we think the most amount of money we could win. But if everybody spends $100 on a ticket, and you can technically only expect to win $42 on a ticket and 43 cents, the outcome, the expected outcome, so the expected amount to earn, and actually, sorry, I have these in the reverse order. It should be the 42, 43, subtract the 100. So we're going to end it with a negative value, but I'll subtract them anyways in that order. It'd be 42.43 subtract 100 equals negative $57.57. So negative, this is what you expect to get, $57.50. Say 57.57? Yeah. Oh, wow. Okay, so that's what you can expect to earn. You most likely, if you pay $100, you're gonna you're gonna lose money because your expected outcome in terms of earnings is $42. So the expected value of a ticket is negative $57.50. But say you decided to purchase all of the tickets at this rate, and they got them for $45. So this whoever organized this lotto did thought about it quite a bit, and still, you don't ever expect to make more money than the tickets would sell for. You would still technically lose. Your expected value would be a negative, and we'll subtract these two again, 42.43, subtract 45, and your expected value would be negative $2.57, so negative $2.57, which is not terrible, right? And that's donating. And really what this difference is, this is your expected value. So we expect if we buy them all at this rate, expected value of a ticket is negative $57. If you buy them all at this rate, expected value of a ticket is negative $2. This is the profit. Okay. So if these are the two extremes. These are the absolute highest and the absolute lowest. If all tickets were sold at this price, you would take this number, multiply it by that, and that's how much profit they get. And we can quickly, it'd be cool to figure out how much profit they're getting as a business. 57.57 times 122,839. They should make, oh my, 7 million. 7 million at the highest. And not all tickets will go at that amount, right? And at the absolute lowest, and again, they all didn't go at this amount because I bought one at 100, so there's definitely less. The other possibility is at $2.57, they're $122,839 tickets. They would only make $315,000. A significant difference depending on what rate the tickets are bought. But at no point are they going to lose any money because the expected value is never at what the lowest possible rate you could buy a ticket is. Okay.